Okay, so my name is Kams Yeung. I'm one of the network architects from Akamai Technologies. So today I'm going to talk about the Akamai Cdn, how do we do peering, and of course some traffic trend that specific to Myanmar that we observe. So this is the agenda for today that I'm going to talk about. I'm going to go through just 2 slides about Akamai, and then we talk about how CDN works, because we are a CDN company. And then we talk about how Akamai collaborate with the Myanmar network operators and how we deploy in Myanmar. And the last, I'm going to talk about some traffic trend that we observe from Akamai's perspective, like Ipv6 and general traffic growth. So first, who is Akamai? So just in case you don't know, we are a leading provider of a cloud platform. We deliver a lot of content to end users, and we also do a lot of application installation and security, etc. And we do that because we have an Akamai intelligent platform that's called, and it consists of a very distributed platform that we have a lot of servers worldwide. So this is probably not the latest figures, but I think we have more than 325,000 of servers and deployed in more than 1,500 networks. And last year, during the pandemic, we delivering over 140 terabit per second for our peak traffic. Of course, this is the last year data, and our traffic keep going every day. And next, so because Akamai is a CDN company, so I just want to talk about some very basic of technology that we use for delivering CDN. So by CDN, actually what I mean is we deliver content to the end user. So the best way, of course, is we deliver the end user to the most optimal server. So what I mean is usually if it is close to the end user in terms of network, then we have the better performance. And there's 2 ways to redirect the users to the optimal server. There are 2 common ways. Of course, there are many ways, but just 2 of the more common ways. One is using Anycast. That means the servers are located in different locations, but they are all having the same IP address. So the user will using BGP to send the traffic to the closest Anycast node. So I think a lot of the other CDN provider, they are using these technologies. But in terms of, and the other CDN technology is DNS, which is what Akamai is using. So Akamai is based on the user DNS IP, and then we based on their IP, and then we map them to the closest Akamai node. I think there are actually pros and cons for both technology, but these 2 are the most common way to do CDN. So as I mentioned, there's a Anycast. So you can see that the orange boxes are the cache server, and then we have a lot of users. So they're all having the same IP address, so they allow the same IP block to the public internet. And the end user will just route to the closest node by Anycast. It actually depends on the user network, the ISP, the BGP routing to see where is the closest node. And the Anycast is not only used for DNS and a lot of it's not only used for CDN. A lot of DNS provider, they are also using Anycast. So basically, the user by BGP go to the closest node, and then of course the CDN node don't have the content in the first place, so we have to go to the origin server to fetch the content. But once the content are fetched in the cache server, then the second user, when they get the content, they don't need to go to the origin again. So basically, the CDN server are caching machines. So they cache the content when it's stored there. Then so the upcoming user, they don't need to go to the origin. So that means it saves the bandwidth to get to the origin. It's also helping the user to get a faster response, because now they can get the content from a closest server. And the next is Akamai Cdn, because we are based on DNS. So you can see that this is an example, and it's actually a real example that you can see that when different user in different locations, assuming they are using different DNS IP, then we will giving out their different IP address. In this case, I'm using a popular game website, PUBG. So you can see that for this content, it's actually, first of all, they CNAME it to an Akamai hostname because they are using Akamai. And for the same hostname, if they are in different locations, so let's say if one user in Yangon, then we will resolve them to this IP address, 45.120.84.24. And if the end user is in Mandalay, then it's a different, using a different DNS, then we actually resolve them to a different IP address because we can recognize the different DNS IP address in different locations so that we can know that, okay, so for Yangon user, we map them to our Akamai node in Yangon, and for users in Mandalay, then we map them to our cache server in Mandalay. I will talk about more about how the detail of the DNS mapping later. So, but the DNS is not the only criteria that we map traffic, because this also have to depend on a lot of different criteria. For example, if that node have that content, a typical content type is, let's say, if we have HTTP node with a particular cache node, then we can serve HTTPS, for example. So we do have different cache node with different type of content, and different content with different cache nodes for different content. So, and the other thing is we also measure the latency and packet loss, so that we check which node that have the best performance to the end user. And of course, it's also dependent on our cache server resources. If it is high CPU or the display is full, etc., then we can map that user to the node because the resources are full. And finally, of course, if that node have bandwidth are full, then we also won't map that to that. So other than the ISP DNS, we also depend on a lot of other factors that to map. But ultimately, we are trying to map the user to the closest Akamai cache server as close as possible. And yeah, this is the simplified version on how we do the DNS-based mapping. So you can see that the first step is the end user requests a content. So in this example, in this slide, I'm using www.example.com, and they send a query to the ISP DNS. And let's say the ISP DNS IP address is 1.2.3.4. And this ISP DNS will follow the query, go through a repeated recursive lookup because it has to go to the root server, the root DNS, the .com, and then essentially go to the example.com authority DNS server. And then you will return a CNAME because they are using Akamai. So we return a CNAME called, let's say in this case, I'm just make up called a212.g.akamai.net. And then because it's a different host name now, so the ISP DNS have to resolve it again through the repeated recursive lookup. But then essentially, because this is an Akamai.net domain, so we will go to the Akamai DNS server. And then Akamai DNS server will know that, okay, this request is actually coming from this particular ISP 1.2.3.4. And it is requesting a content for a.212.g.akamai.net. So based on the DNS IP, and based on the other factor that I mentioned before, we'll say that, okay, in this case, then the best Akamai cluster to map for this end user will be with our cluster IP 5.6.7.8. So then we return this IP address 5.6.7.8 back to the ISP DNS and then back to the end user. So now the end user get the IP address of the most optimal server. Then the last step will be the end user send an HTTP request to that server, 5.6.7.8, and then we deliver the content to the end user. So just to repeat again, because this is a quite important. So number one is we don't map based on the end user IP. We map based on the ISP DNS, and the Akamai DNS is actually the one to handle the IP address to the ISP DNS. And there's also a lot of other factors besides the DNS IP. We also based on the memory utilization, server loading, content type, etc. So, but this is a very high level overview on how we do the DNS mapping. So there's one step, the DNS lookup to look up the IP address, and a second step to actually deliver the content through HTTP or HTTPS. Yep. So the next session I'm going to talk about how Akamai deploy in Myanmar. So they will cover our CDN log in Myanmar. How do we do peering, or how peering with Akamai will help you, and and last is we are talking about how we cooperate with MMIX. So first, Akamai CDN. So Myanmar, of course, is a very big country, so we can't deploy server in everywhere, every city, right, or every network provider. But we do have deployment in all the major ISP. The top few network operator, they already have Akamai cache server, and we deploy in Yangon and Mandalay. As long as the ISP have the DNS deployment in that local city, then the traffic are justified for that deployment. Then we will deploy in 2 cities. So we do have some network operator that we deploy in 2 cities. Some we deploy only in 1 city. So it's depend on the ISP DNS architecture and their traffic demand. At this stage, we are having more than 70% of the Akamai traffic we are delivering within Myanmar. I'm expecting this traffic will go up because we are deploying with more network operators, and also, as I mentioned, we are going to connect to MMIX later. So we are able to also connect to more ISP through MMIX. So the traffic, hopefully, in a few months' time, then we will be able to reach to 80% or even 90%. And if we are not able to deliver within Myanmar, then most of the traffic are actually will overflow to Singapore and Thailand, because the international capacity of Myanmar is usually going to Thailand and Singapore. And then from there, it's either through the ISP upstream or through the peering, then we deliver the traffic back to Myanmar users. And the latency is not that bad because Thailand is like a adjacent country for Myanmar. So in case you don't have in case you're a network operator and you don't have an ISP cache server now, then what you can do is you have a peering somewhere else, let's say Singapore or Kuala Lumpur or Bangkok. Then as long as we are in a common IX or a common data center, then we are happy to peer with you because we have an open peering policy. So by peering with Akamai, then what will be the benefit? Then of course you have improved performance because you remove the third party in between. You remove any potential additional network congestion. And shorter latency always means better throughput by TCP. And even you have a on-net cache server with Akamai, then I also recommend you to have a peering with Akamai, because cache server could go down, unfortunately, or if we need some overflow or failover traffic, especially during an event, let's say a game download, the on-net cache server may not have enough bandwidth, then we need to overflow to the peering link if you set a peering with us. And of course, if you have peering, then it also help you to reduce your cost. With the peering, then we get the BGP information. Then we also help us to do a better mapping, because sometimes we also based on BGP a little bit based to map the traffic. And as I mentioned before, even you have an on-net cache server, it's also very welcome you to set up a PNI, either per peering or PNI with Akamai. Yeah. So in short, that if you peer with Akamai, then you get a better performance and you probably have some cost saving as well. But the thing that you have to bear in mind, even you have a peering with Akamai, is that you can't get all the content through peering, because sometimes we will choose to deliver via on-net cache node. We prefer to send that from on-net cache node rather than peering. But if you only have peering, then we also depend on where we have the optimal node, because where we have that content or where is the most optimal latency. So just to aware that peering with Akamai doesn't mean that you will have all the content delivered. But I would say that it's definitely better than using a public transit. So this is more like an announcement that we are going to connect to Myanmar so that we can have a node that we can do public peering. We are cooperating with Myanmar, so thanks for kind that we have a long discussion. And now we come to a fruitful production that I think the server are already in Myanmar. We are just missing some of the last missing piece then, but we expect that they will be complete soon. So our deployment will be in true RDC where MMIX is in. We are going to start with a 20 gig MMIX port. And we already have the IP address, aside from MMIX. So when we are ready, then please feel free to send us a peering request, and we will be setting up the peering with you. But just one reminder again, so even you peer with Akamai and MMIX, you probably can't get all the content because we are going to start with only HTTP content in day one, and then depending on how the traffic grows, then we probably expand our cache node or adding our port capacity with MMIX. Yeah, so stay tuned. Hopefully by next month, then we are able to set up a peering with the MMIX members if you are one of them. If not, then you could also consider to connect to MMIX because when we are ready, then we could send traffic to you from there. Yeah, so and this is a very simple way that how we deliver traffic to the MMIX members. So we do have the cache server in true IDC, and this node have two links. One connect to MMIX, of course, and IX link, and then from there we will have peering with all the MMIX members or with the route server, and we have another link through transit that allow us to fetch the original content from our customer. So this is a very high level of traffic flow. So when user requests traffic to the Akamai cache node, then we have to fetch it from content, and then we send it through the export back to the MMIX members. Okay, so next, I'm going to talk about some traffic trend that we observe from Akamai's perspective for Myanmar. So number one is in Akamai, we actively measure a lot of the internet performance because we have to map traffic based on performance. So we do collect data like how many users are connecting to us using V6. And we collect a lot of different data, not only V6, but and we publish a report called SOTI, State of the Internet Report, and you can check out on our website. And if you are particularly looking for V6 data, that's like you can go to stateoftheinternet.com/Ipv6. And this is a snapshot data that I captured probably 2 weeks ago on the Akamai SOTI report. We do collect information based on per country level and also based on per network level. So you can see that on a global level, the number one V6 deployments in India because they have a very high youth growth of internet population, and they have a lot of mobile users. And the next is like some European country, Belgium, Switzerland, and United States. They all have like more than 50%. Even like Malaysia, I think that now they're also popular in deploying V6. So you can see that the top 5 countries that this year, they all have more than half of their end user using V6. And this is the data they collect from Akamai. Doesn't represent the whole internet. And the next is we also collect data based on network operator. So I don't spell the name here, but you can see that a lot of them are like US operator, and of course the India one, the Geo, they have 92% almost for V6 user. And Japan also have 70% for KTDI. Next is the Ipv6 adoption that we observe. So Myanmar, that we observe about 14 to 16% of Ipv6 adoption. And this is trend that we observe. So so I mentioned this is like 14 to 16% that we observe. And as of 2 days ago, and in terms of country ranking, Myanmar is like 41st in terms of country ranking. Not that bad, but I think there's room for improvement. And if you want to compare that with for other IPv6 measurement, then Google say Myanmar have 12.49% and APNIC data say Myanmar have 19.7 because they have different measurement methods, right? So the data could be different. So we measure 14 and then Google is 12 and APNIC is 19. So we all use different methodology, but you can see that if you see the trend, definitely has been increasing since like 2 years ago, 2019. Then up to now is about 14. I'm hoping that this will continue to grow, essentially like more than 50% or even 90%, because IPv4 is getting more difficult to collect. And we measure also based on the new operator. So what we can see is most of the ISP that have enabled, or sorry, major of the ISP that enable V6 from the Akamai perspective is Mitel. Not all the network operator have V6 enabled with Akamai. If you have a peering or you have an on cache with Akamai and you have IPv6, please feel free to contact us to enable that. So chances you may have an IPv6 enabled already, but you just don't have the V6 connectivity with Akamai. So if you have V6, then please contact us to set up the peering. Next, so since Mitel is the majority of the V6, so we drill down to look into specific for Mitel, which is a fast-growing mobile operator in Myanmar, and we see the traffic trend here. So from 2 years ago, from I think this is about like June timeframe, that 2019, they start to deploy V6, and you can see that it's like a sudden jump from there, and then it's going steadily. And as of a few days ago, we are seeing that they have 61.8% of users using IPv6. And globally, Mitel is ranking 143rd in terms of our SOTI ranking. So if you are interested, APNIC actually published a board about how Mitel launched IPv6 in Myanmar. So you can take a reference. I think this is a very good example of deploying V6 in Myanmar. So you can take a look at that. I set the URL here, so you can take a look. And I think this is the last slide. So and then we measure the whole traffic from Akamai perspective to Myanmar. So you can see that, of course, I had the scale here, but this confidential information. But you can see that the traffic growth from here, the beginning of January 2020, up to the end of 2020, because I want to measure a 1 year trend, the traffic growth about like 3 times for Myanmar. So there's of course a lot of factors, and one of the major one I think is like the COVID-19, a lot of lockdown, people stay home, and they are like watching movies or like downloading games. So it's we observe this kind of trends everywhere, not only Myanmar, but Myanmar is actually going more than that, because I think it's also contribute to like a lot of more social media, because Myanmar is a young nation. And also a lot of internet adoption is growing, like 5G network, broadband penetration. So I do see that in terms of growth rate, Myanmar is definitely one of the top in terms of Asia, because you can go 3 times in a year. Of course, in May time, you can see those bursts is more like a pandemic, and then, but it's still steadily growing, and I'm sure that it will still continue to grow in the coming few years. Yeah, so that's all my presentation. You can ask your questions in the chat box, right, or Q&A. So I just want to summarize my presentation here. So number one is Akamai Cdn is an intelligent platform, which is a highly distributed edge server. We are a DNS based mapping CDN. We do deploy cache server in Myanmar so that we can have a better web experience for the Myanmar users. We encourage you to have a on a cache server or a peering with Akamai, so that it could help to improve your user experience, reduce your transit costs. And we also partnering with MMX. So by next month, so please contact us you can contact me or send an email to our peering team so that we can set up a peering with you over MMIX. And we do see the internet traffic is growing rapidly in Myanmar. But unfortunately, V6 is still limited ISP from what we observe. So we hopefully that more ISP will deploy V6, and hopefully the traffic will continue to grow in Myanmar. So that's all my presentation. If you have any questions that you can send email to me, or if you are interested to peer with us, not only in MMIX or we can anywhere, then you can go to our PingDB and drop us an email. And if you're interested in our internet measurement, not only V6, you can go to our SOTI report website. So there's a lot of other data that you can see. With that, that concludes my presentation. So thank you.
Any question? You can raise hand from Zoom if you want to ask a question, or you can type Q&A session. ကျွန်တော်တို့မေးစရာရှိရင်ကျွန်တော်တို့ဟိုပါနော်အဲ raise hand လုပ်လိုက်လို့ရတယ်နော် raise hand လုပ်ရင်ကျွန်တော်ဒီဘက်ကနေဟို moderator unmute လုပ်ပေးလို့ရတယ်နောက်ပြီးတော့ကျွန်တော်တို့ဒီဟိုနဲ့ question and answer session မှာလည်း type ပြပြီးတော့မေးလို့ရတယ်နော်
I don't know. If no question, I think maybe we go to the quiz.
So, okay, we will start our quiz.
Okay. Thank you again. I'm stopped sharing the screen now.
Actually, I have one question.
Oh, sorry. Go ahead.
Okay, so right now, if we want to peering with your Akamai, right, we can only peering at Singapore or Bangkok.
No, you can peer with us anywhere as long as we are in the Akamai. So I'm just saying that because of the network performance, so peering in Bangkok, KL or Singapore would make more sense. Because let's say if you peer with us in Japan,
my question is when can we expect to peer in locally here? Is there any plan from Akamai to put the POP in Myanmar in any new feature?
We do have cache server already in Myanmar, but if you ISP that you don't have an Akamai cache server, then please drop an email to me, then we can discuss, because we do require some traffic level so that to make sure that the cache server are going to be efficient. So we don't install Akamai cache server in all ISP, because you got to be have some enough traffic so that your cache is going to be efficient. So at this moment, we are requiring at least like 5 to 10 gig of Akamai traffic.
My question is like in the near future, right? Do you have any plan to put your PE router or POP in Myanmar so that every ISP can peer locally? Not about the cache.
Sorry. At this moment, we don't. With this moment, it's more like a pure caching model for Myanmar. So we don't. We are not going to put a, like, let's say what we call an edge POP or infrastructure POP in Myanmar. At this moment, we don't have any plan, unfortunately. But yes, if the traffic really grows a lot in future, then we may consider one.
Okay, thanks for your answer. Thank you.
Okay, no problem.